All right, these are the notes for Unit 8, Day 1. I'm going to try to keep this video under 10 minutes. Feel free to pause if I'm moving too fast. We're going to start talking about imaginary numbers. The big takeaway today is that when we see a negative underneath a root, we're going to open up our numbering system to the complex numbers. So this doesn't change our simplification much, except before we simplify, we are going to get the I out. So as soon as you see a negative underneath a root, the first thing to do is to get the I out. I kept my perfect squares around. If you want to pause the video and write down the perfect squares, now might be a good time to do that. Let's start with example number 1. So on this one, we are going to get the I out first and rewrite it. And now we see that we can simplify that root I. Well, if we can simplify that root I, there are no perfect square factors, so that is simplified. So before we perform any kind of operation, we're going to get the I out. So on the next one, we have root 20. We are going to get that I out. And now I'm going to look for the perfect square factors of negative 20. And those factors are, well, the perfect square factor is 4. The other factor is 5. And normally we would simplify this to 2 root 5, but we had that I in there. So we are going to simplify to 2I root 5. So same idea, same type of simplification as before. This next one, I'm going to get that I out, so I have 9I root 40, but I'm not done. Once again, I've got to look for those perfect square factors, and I go through my list. I know that I'm not going through the process I normally go through, but the same ideas are there. I had 9I. I'm going to multiply it by that square root of 4, which is 2, so that will give me 18I, and then we just have the root 10 left over, and that is simplified. So bottom line, we don't want to do anything until we get that negative out, that I out. All right, now what we're going to see is we're going to see that different powers of I will reduce. We never ever want I to be higher than the first power, and we can simplify that using kind of dividing by 4 to keep it simple. So what's going to happen is we're going to skip this table. And what we have is I to the first, just like any number, is I squared. Is itself. I squared is going to be I times I, which is the square root of negative 1 times the square root of negative 1. So that'll be negative 1. If you multiply those two together, you'll get negative I, which is I to the third. And then I squared can be thought of as, or I to the fourth can be thought of as I squared times I squared, which would be positive 1. And then these are just going to keep repeating. So when I do, for example, I to the first times I to the fourth would give me I to the fifth. That's 1 times I. That's I. And if I kind of just keep repeating that process where I go, okay, well, 2 I to the second times I to the fourth is I to the sixth. That's negative 1. And if I just keep doing that, I to the third times I to the fourth would give me I to the seventh. And you could tell that pattern is just going to keep repeating and repeating and repeating. So every fourth power, doesn't matter how big that power gets, the term is going to repeat every fourth power. So there's a really easy way to do this using the calculator. And what we're going to do is we're going to take the exponent, divide it by 4, and whatever is the remainder, that tells us what position it is. Is it an I squared, I to the third, or I to the fourth position? Meaning, is it I, negative 1, negative I, or 1? So for example, when I do 81 divided by 4, right? I just go ahead and I type that in my calculator. I'll pop my calculator up here real quick. 81 divided by 4. The 0.25 is all I care about, right? I'm not even going to write the rest. I go to my chart. 0.25 is the same as I. This just simplifies to plain old I. Okay, the next one, 46, I'm just going to do 46. Oops, that's 49. 46 divided by 4. That gives me a 0.5, right? Again, notice how I don't even care about the fact that it was 11.5. That is in the position of I squared. 0.5 simplifies to negative 1. Okay, we're going to bounce around a little bit here. I'm going to come back to 9. So then when I go over here to 9, I'm going to do 142. Throw this over here. 142 divided by 4. And I type that into the calculator. Oops. I clear that out. 142 divided by 4 is another 0.5. Again, we don't care about the 35. We just care about the 0.5. That will simplify to negative 1. So when you do those other three on your own, just pay attention to the decimal. You go right up to your chart, and then that will tell you how to simplify those. Now, when we write these in complex form, what we really care about is we always want the real first, and then we want that complex part. So if you have I, it's kind of like the opposite that you would expect. You would expect the I to come first because we're kind of treating it like a variable sometimes, but we're not going to do that. So for example, on this first problem, the very first thing I want to do is get this I out, right? When I have I root 9, that root 9 becomes 3, so this term is going to change to 3i. Now I have this minus 14 over here. What do I do with that? Well, I want the real part first. So this is an okay way to write it, but the best way to write this in standard form would be negative 14 plus 3i. When we start solving quadratics, you're going to see that that's the way that we want to write that. Okay? Now, if we have something like this that we can't simplify, or I'm sorry, that is not a perfect square, we're going to do our normal thing, right? We're going to find our square root. And the other factor here, I get 2i root 10 plus 9, which is good. All the values are good, but we don't have this written in order, so I want to make sure that I'm writing this in that complex form with the real first and the complex second. Okay, so for those problems that have roots, all you're doing is getting the I out and simplifying. So you're going to try 14 on your own. And then example number 17 is going to help us do those other ones. So on these other problems, here we want to remember that I to the first is I squared is negative 1. So I'm just rewriting these values from the chart above. And I to the fourth is equal to 1. Notice we didn't get any out of whack values here. So what I'm doing here is I'm going to rewrite these, but instead of I squared, let's use a better value than that. I don't want my I to be higher than the first power. I to the first is like having a negative 1, so it's like 8 times negative 1. Then I have 4 times, well, that I to the third changes to negative I, and then I just multiply. So negative 8, and that would be negative 4i, so we're going to say minus 4i. So this is just another way to write it. This is going to help us when we start multiplying complex numbers, because sometimes we'll get I squared, I to the third, I to the fourth. We don't usually get very large exponents. We stick with like those first 4. But we're never simplified until I have I to the first, or some version of positive or negative 1. All right, in class today, we're going to complete the even problems. Thanks for watching.